Welcome back to lecture 4 of our two-dimension kinematics equations. In this one, we're going to throw it at still throwing it at an angle. We're not going off a cliff. We're throwing a ball or shooting a shell at an angle, and we want to know where it is at a certain time. And so these are our two equations, and we're trying to find the y. In other words, how far is it vertically upward, and how far out has it gone? So if you think vertically, back in the second lecture, our sine is our vertical, cosine is our horizontal, except we're having to put an angle on this. In this one, once we're vertically, as you know, anything vertically has gravity affecting on it. So as soon as you release it, it's vertically. Gravity is trying to bring it back down, so we're having to subtract our g right here. So say, for instance, I've got a ball thrown at a velocity at an angle, and I want to know its position after 3 seconds. In other words, I want to know what is my x and y coordinates. So I'm going to say x is equal to vt cosine of the angle, and y is equal to y naught plus vt sine of the angle, and there's where we're taking in the gravity affecting it, trying to make it go back down. And so all I'm going to do is just plug it in. Okay, there's 30. My time is 3. And my cosine, since I'm dealing with the horizontal component, 20. Make sure that is in degree mode. X will be in meters, and you can actually use feet if there's in feet per second, or kilometers if you're dealing in kilometers per second. But make sure all your units are consistent. Okay, now the y. Now there's no y initial, so we're going to assume that's our reference point there. It's going to be 0. Plus and then we're just putting these in, 30 times the time and the angle, 10. Your teacher might have you put 9.8, and y is equal to meters. Let's look at the next one. Okay, we have a shell. You know, some teachers like to use artillery so they can play with some big numbers instead of these small numbers. Like to deal with big numbers. There's our angle. And I want to know where it's its position after 10 seconds. So I'm going to put the t there and there, even though that's the seconds there. So x is equal to vt cosine of the angle, and y is equal to y naught plus. And make sure, if you do that, write the naught, make sure that it is a subscript, not the same. It looks like y times 0. Somebody might, looking at your paper, might mistake it for that, get the wrong answer. And we're going to find y. So there's 350 times 10 cosine of 30. As we know, x will be in meters for what we're dealing with today. And there's 0 plus 350 times 10 sine of 30, 1/2 times 10, 10 seconds squared. And don't forget the square. Your answer will come out really messed up. In other words, wrong if you forget your square. So that's how you do it. You're just plugging your information into your equations. Next one, and I'm going to draw down here. This now remember, we're going at, say for instance I start here, so there's my reference point, and it's going like this at, so here's an xy, and here's an xy at t. Now, depending, your professor, teacher, may have just thrown in some numbers that it actually is right here. So I have x, but I have a negative y. So don't panic if your y becomes negative. That just means, if we think about it, like our cliff, we're throwing it off of a cliff. You can laugh at my drawings. Okay, balls throwing, you're throwing off of a cliff, boom, 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 boom. And then, if we use this reference point, down here it's minus y, whereas here it's plus y. So don't panic if your y is negative. If your x is negative, check your calculator. You probably got it in radian mode. But remember, x will always be positive. So let's just say x always positive. So if you get a negative, you might want to check. And the y can be either negative or positive. Now this would be, now if I wanted to take in this person, you know, I could say that they're 2 meters, so that I could say, I could call this y naught 2 meters and just plug it right there instead of calling it the 0 point. So look at your equations. You can plug these in. You might have to find time. Remember on this, if you have to find time, it's nothing more than a quadratic equation, and use quadratic formula to calculate that. Enjoy the rest of the problems. Remember, if you have any questions, don't hesitate to contact me.